So I wanted to show you all this little math project that I've been working on. I was really intrigued by polyhedra, and polyhedra are these geometric solids that we often learn about in math class. Things like cubes and rectangular prisms, tissue boxes, soccer balls, D&D dice, and the cool thing about them is that when you take the solid, you can unfold it into a net, which is what I have in this little screen here. And with that net, you have a two-dimensional representation of one single surface. And so that means that if you draw a line on it, if you drew a line in the coordinate plane, it would extend off into infinity. But on this, on the surface of this net, it wraps around itself and it loops around on like a single isolated surface. And so in order to try to see what would happen if I plotted a line on a net, I decided to write this Python turtle function to demonstrate the results. And Python turtle is pretty cool. Python turtle is a library in the Python language, and it has this little turtle, which is the triangle you see here, and you can give the turtle these simple commands like move forward a certain number of pixels, turn a certain number of degrees, and when you combine all those together, you can often make some pretty intricate designs. And so what my code does, this is the algorithm I wrote. First, it defines all the edges of the cube, or the prism. It can be a cube, such as the coordinates, the angle of each edge, and then the faces. So, for example, A0 shares a face with F1, B0, and H0, and its coordinates are defined by 0, 0, x0, where you can plug in x later on, depending on how big or small you want it to be, and then 0 because the edge A0 lies horizontal. And then this part shows how for each edge in the edge list, you can tell the turtle to put the pen up, then go to the first coordinate point, put the pen down, and then go to the second coordinate point, which effectively draws the edge, and it repeats this for all the edges in the polyhedron, which is what you saw in the beginning there, where the turtle was jumping around on this blank screen. And then this is sort of the math behind it, where, if you're given a starting point and an angle, you are on a face and you want to find the next place that it goes to. And so, since you have the angle, you can write this equation, y equals mx plus b, for that line, and then you also have the coordinate points of each of the other edges on the face, so you can just write a little function, just like in algebra 1, like y equals mx plus b, and then you solve for the next xy. And after that, I wrote this little jump function where you get the next x and y, and you also get a new edge, a length on that edge, and an angle, and you repeat the process again, and you keep going and going and going. So here, I told the turtle to draw a prism with dimensions 200, 50, and 30, and then I said, starting on edge A0, which is this edge, move forward 30, and then turn 32 degrees, and start going. And this is the design that it made. And the idea is that you could print this out, and then cut it into the net, and fold it back up into the rectangular prism, and you get something pretty cool. Thanks!